Hello, my name is Darren Holmes, and today in the book Get Started with MicroPython on the Raspberry Pi Pico, we're taking a look at chapter number 9, Data Logger. So data logging is going to be all about using MicroPython's filing system. We'll be storing our information onto that 2 meg of RAM that's built into your Raspberry Pi Pico board. So just as a reminder, from our schematic, here's our RP2040, and over here is our 2 megabyte of RAM. And you'll notice it's the W25Q16. And we went out to DigiKey and typed in that part number, and we found out that it was 16 megabit of RAM. So scrolling down the specifications, we found out that 16 megabit is actually 2 megabytes by 8 bits wide. So most of our data is 8-bit data, and 8 bits is called a byte. So we have 2 megabytes of RAM. So starting off, it says the file system is where your Pico stores all the programs you've been writing. It says it's equivalent in function to a micro SD card, or a hard drive, or a solid state drive, or a USB thumb drive. Just keep in mind, right, when we press that boot select button down and we plug it into our computer, we do not have direct access to the files that are stored on there. Not with MicroPython anyway. So just keep in mind that when we store our files on that 2 meg of RAM, that we're not going to be able to access it directly from Windows Explorer. So we're going to start off by connecting our Pico to our laptop, and what we're going to do is use the shell area to explore some of these commands. So I've loaded up Thonny, and you can see I have nothing here. If I go to File and I say Open, I can open from this computer or my Raspberry Pi Pico. And if I open from the Pico, you can see I have nothing stored in there. So I've deleted all the files that were originally in there just for this demonstration so I don't confuse you with a lot of different files. So I'm going to say Cancel. So down here in the shell area, we're going to create a file. So all we do is type in File, and File is basically a variable name. Now obviously it's going to point to an object, but you can call it anything you like. You can call it File1, you can call it My File, doesn't matter. The book just uses the word file. So we say File equals Open. So now it knows that we're going to open a file. We have to use our parentheses, and we can give this file name any name we like. Okay, they call it test, and it's going to be a text file. So a text file is anything that stores letters or numbers, but the numbers are not stored in number format. They're stored in text format, so keep that in mind. And then we have to tell Thonny how we're going to open it. So the W means we're actually going to write to it. So we can go ahead and press Enter, and nothing happens, but it has created that file on that 2 megabyte of RAM. So the next thing we need to do is write something to it. Now I should mention that when we create a file with the W option, it's going to create a brand new file. So if some data had already been stored there, it's just going to wipe it out. Okay, so keep that in mind. So the next thing we're going to do is a file. Now keep in mind, file refers to the name that we gave to this thing. Okay, so we do file.write, and keep in mind write is a method, and then in brackets we're going to type in what we want to put in there. So in this case it's hello and comma file, and we're going to press Enter. And it comes down here and gives us a number, 12. That's the number of bytes it has written to the file. So if you count your letters, you can see H is 1, 2, 3, 4, 5, 6, 7 is the space, 8, 9, 10, 11, 12. So it stored 12 bytes of data. Remember, the bytes are going to be stored in ASCII code, right? So ASCII code is 8 bits. So just keep that in mind. Now, just like in Windows, when we write something to a USB drive or a hard drive, it's stored in a buffer. So we have to type in here file, and we have to type in close. And that stores that data into the file, and now it has closed the file. So we're going to go ahead and reopen that file. So if you've typed stuff into the shell area, you can use the up and down arrow keys to actually find stuff that you've already typed. So every time you press the up arrow, it brings back stuff that you've typed previously. Okay, so we need to open this file for reading. So instead of W, we can put in an R. Now the default is R, so we don't actually have to type that in. We can just open it just like that and press enter. Now if we want to see what's in the file, we use file.read. And remember our little brackets. And then it comes up and tells us what was in the file. Now we only had one record stored in the file, so now we have to close it. So now our file is closed. So if we want to write something to it, we can go back and do a file open, and we want to do the open with the W on there to write to it. And now I want to write something to it. So instead of saying hello file, what I'm going to do is type in something different. Hello class. And the reason I want to write something different is to show you what happens with our file. Now you can see it's still written 12 bytes. So I'm going to come up here and close it. And then I'm going to open it for reading. And then I'm going to read the file. And notice it says hello class. So before we had written to it hello file. And now the contents of the file says hello class because we opened it with the W. So whenever we open something with a W, it's going to overwrite an existing file. So I want to show you one more thing here. This is not in the book. So I'm going to open the file. Instead of W, I'm going to open it with an A. A is for append. So we can actually add data to our file. So I'm going to come in here and I'm going to do a file write. So this time I'm going to say hello file. Okay, so it's written 12 bytes. I'm going to come up here and close my file. Then I'm going to open my file for reading. And then I'm going to read my file. So file read. So now you can see it has several pieces of data in here. It has the hello class followed directly by the hello file. So when I open my file with the A option, it does not overwrite my existing data. It actually adds to the end of the file. So sometimes you want this to happen, especially if something like the power goes out and then you start writing to your file again. You don't want to overwrite it. You want your existing data to be there. So you notice in the book they do have a talking point saying warning, opening the file for writing in MicroPython will delete anything you've already stored in it. And it says always make sure you've opened the file for reading and saved the contents somewhere if you want to keep it. So we can actually use the A for append, and it won't delete our data that we already have in there. So in an earlier chapter, I went over the OS library with you. I went out on the internet, and this particular gentleman has done a really good job. It's a short 6-minute video, and he covers some of the things that I went over with you. How to remove a file, how to make a directory, change a directory, list a directory. So if you've forgotten how to use the OS library, I recommend that you go to YouTube and watch this video here. Secondly, I want to remind you that I did show you w3schools.com, and they have a whole section on Python. So they've got an area on file handling. If you want to know what any of these different modes are, you need an example of how to read files, or if you need further examples on how to write or create files, or how to delete files, I recommend that you do check out the W3 Schools website. So in the next section of our book, we're going to be logging temperatures. So they've given us some code to type into Thonny. I'm not going to show you me typing it in because I type awfully slow. So here in Thonny, I've typed that code in, and you'll notice it's the same code that we used in Chapter 8 when we did our temperature sensor. But this time when we get to the end and we've done our temperature conversion, we're now going to open a file called temps, and we're going to open it for writing. So it's going to either create a brand new file or overwrite a file that already exists. We're going to go file write str temperature. So keep in mind, temperature is the reading with the conversion, and it's a floating point number. And it's floating point because it has a decimal point and some digits after the decimal point. So we can't write numbers directly into the file system. It has to be a text type, letters, numbers, that kind of thing. So we use the str function. So str converts a number into a string. So we're going to convert temperature into a string, save it into our file, and then we're going to close the file. So what we're going to do is we're going to save this, and they want us to save it as datalogger.py. So I just wanted to show you this. I'm going to go to File, I'm going to go to Save As, and I'm going to save it on the Raspberry Pi Pico. And when I do that, there is our test.txt file stored on that 2 megabyte of RAM. So then I'm going to save my new program as datalogger.py. Okay, so now I'm going to go ahead and run this. And you notice down here nothing happens. So in the shell area, I want to see what the contents was that was written to that file. So I'm going to come in here and I'm going to open the file. So I use the up arrow key to get me to File Open. And last time it was called test.txt. So you can actually run your pointer, and you can highlight the test part, and we can rename it TEMPS. So now it's temps.txt. So now I've opened that file I just created in my program called Datalogger. So now what I'd like to do is read the contents. So I'm going to come up here and go to File, Read, and press Enter. And you can see that's the number from my data reading. So that was the temperature it read. So 31 degrees, pretty warm in my room right now. So remember, if you want to keep this, we have to do a file close. So there's a file close, and we can press Enter. So following along in our book, it says a data logger that only logs a single reading, called a datum, isn't that useful though. To make your logger more powerful, you need to modify it so it takes lots of readings. So they're going to have us click Run again and check the readings in our file. So up here in Thonny, I'm going to do a stop first, and then I'm going to run it. And I might run it several times. So I think I run it about 10 times. So now I'm going to go ahead and come down here to the shell area, and I need to open the file. So I'm using the up arrow key to find file open temps.txt, press enter. Then I'm going to do a file read, and you can see it's a totally different reading from what I had originally. So then I have to do a file close to close that file. So now we're going to modify the program, and what they're going to have you do is highlight some code, and they're going to do a copy and paste. So Control X is to cut. We're going to put a while true in there. So the book says after pressing enter at the end of that line, hold down the Control key and press V key, and Control V is paste. So it's going to paste those couple lines that you just cut out of there. And then we're going to use a new method called flush. So we're going to do a file.flush. And what a flush does is actually writes the data from the buffer area onto that 2 meg of RAM. So it just moves the data onto the 2 meg of RAM rather than storing it in the buffer. So it says here it's equivalent to a file close, but it does not close the file. It just pushes the data from the buffer to the file. And you can see we're going to have a 10-second delay between readings. So then it says your finished code should look something like this. So I'm going to show you a little shortcut today. What I'm going to do is I've got the PDF of the book open right now. So you can see my cursor turns into an I-beam over the I of import. So I'm just going to hold down the left mouse button, and I can highlight all of this code all the way down to the final parentheses. So I'm going to do a right click here, and keep in mind I'm using Windows 11. I'm going for the copy command. Yours might look a little bit different in Windows 10 or Windows 11. So I'm just going to do a copy. Then I'm going to go to Thonny, and up here where I had my original code, I'm just going to highlight all that code and do a right click and a paste. And you can see it's put all the new code in there for me. Keep in mind here where it says while true, all these commands have to be part of the while statement. For that to happen, I need 4 spaces in here, and the copy and paste only gave me 1. So I need to add an extra 3 spaces to each line. So that's a quick way to get your code in from the book directly into Thonny. So what we're going to do now is click the run icon and count to 60. So if we have 10 seconds between each loop, then we should have about 6 readings if we count to 60. And then we're going to open the file and read the contents. So over here in Thonny, I'm going to click on the run icon, and now I'm going to count to 60. So then I'm going to click on the stop icon, and then down here in the shell area, I'm going to use the up arrow key to find the file open temps. I'm going to press enter. And then I'm going to use the up arrow key again to find file read, and I'm going to press enter. So you can see it's taken a whole bunch of readings. How many readings? Well, you can count the number of decimal places. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So I took a little bit longer than 60 seconds to do those readings. Unfortunately, they've all run together, so it's not easy for me to take individual readings and say this is where it started and this is where it ended. So looking in the book, it says the good news is your program has worked. We've got multiple readings. The bad news is they're all mushed together. So in order to fix this problem, we're going to need to format the data as it's written to the file. So we're going to modify the file write command so it takes the string of the temperature and adds in a /n for new line. So I've changed that line in Thonny. I'm going to press stop, run my code, and wait 60 seconds again. So after waiting approximately 60 seconds, I'm going to press the stop button. And then down in my shell area, I'm going to use the up arrow key to open the file. Then I'm going to read the file. And now you'll notice it's put in the /n between the readings. And the book says you've made progress, but it's still not right. And that's because the file read is bringing in the raw contents of the file and making no attempt at formatting it for the screen. So to fix the problem, what we need to do is wrap the file read in a print statement. So when we print contents of a file, if it has a special character in there, it will actually format it for the screen for us. So back here in the shell area, I'm going to open the file again. And here where it says file read, I'm going to put in print. And then remember to close the file read in parentheses. And remember to close your bracket at the end and press enter. When I open up my area a little more, you can see each of my readings is now on a separate line. So your book says, congratulations, you've built a data logger which can take multiple readings and store them on your PICO's file system. It then has a talking point about file storage, and it says your PICO's file system is 1.375 megabytes in size. So we know we have 2 megabytes of RAM, so that means about 700 megabytes is taken up with the Python interpreter. So it says how long it takes to fill the storage will depend on how many other files you have and how often your data logger saves a reading. So currently at 9 bytes per reading every 10 seconds, we're going to fill that memory in about 18.5 days. But if you took a reading every minute instead, your logger could run for 111 days. And if you took a reading once an hour, your logger could run for more than 18 years. So it says here, your PICO's file system works regardless of whether or not it's connected to a Raspberry Pi or another computer. So if you have a micro USB charger, you could run it from that. Or if you have a USB battery pack, you could run it from that. Now the problem is when we plug our Raspberry Pi Pico in, it doesn't do anything. So it says for use without a connected computer, and they've called this headless operation. You can save your program under a special file name. So if we saved it as main.py, it says when MicroPython finds a file called main.py, in its file system it runs that automatically every time it's powered on or reset without having to click run. The other thing to note is it says to force the program to run, what we can do is click in the shell area and press Ctrl D. So this sends your Pico a soft reset command, which will break it out of interactive mode and start the program running. So in Thonny, we have our basic code, and if I put it onto the Pico and run it, how would I know it's running? So what I'd like to do is have the LED flash to remind me that it's running. So on here, you'll remember we used LED onboard many chapters ago, and the onboard LED is on GPIO 25, and we have to set it up as an output. So then I modified the code. After we flush the file, that is, write it from the buffer to the actual RAM, I'm going to turn my LED onboard on, sleep for 1 second, turn the LED onboard off, and then sleep for the remaining 9 seconds. So that's the total of 10 seconds. So what the book wants us to do is come up here and go to File and do a Save As. We're going to save it to the Raspberry Pi Pico. And instead of calling it datalogger.py, we're going to type in here main.py. And we can click on OK. So now it's saved our program as main.py. So now if I come down here into the shell area and I press Ctrl D, you can see it does a soft reboot. So this is my Pico running in data logging mode, and if I hadn't put that LED on to blink, I wouldn't even know that this is actually operating. So if you happen to have your USB charger or a USB battery pack, you can disconnect your Pico from your laptop or computer that you have it plugged into, plug it into the battery pack or USB charger, and just put it in another room or another location and leave it there for about 10 minutes. Then we're going to come back and plug it back into our laptop. So you can see down here they have a talking point and it says warning. Your data logger program will run every time your Pico is powered on without being connected to Thonny. So with this in mind, if you have Thonny running on your computer and plug your Pico in, main.py will not start running, so your file should still be intact. So unfortunately the author has not tried this themselves. As soon as I unplugged my Pico from my laptop, I get the back-end terminated message. So I can't now stop this. You notice it just can't find the device. So as soon as I plug the device back into my laptop, so as soon as it starts running the code, it's going to do a file open with a write. So if there was data in my file, it's just overwritten it now. So what I'm going to do is press stop. And in here where I say file equals open, instead of opening it with a W for write, I'm going to open it with an A for append. So now whenever I plug my Pico in, it will actually open it for appending, and it will not delete all the data that's already in there. So I'm going to go to File and Save. So now it's saved main.py back onto my Pico. It's ready to go. Now because I've been playing with this for a while, I've already got that file on my Pico. So I want to get rid of that. Now I have shown you before how to import OS, but another way to do it is to come up here and go to View, and on View select Files. So now you can see these are the files that are on my laptop. These are files that are on my Pico. So down here I have one called temps.txt. So if I do a right click on that, you can see I can delete it. It says, are you sure you want to delete temps.txt? I'm going to say yes. And please note it does not go to a recycle bin. There's just no way to undelete the file once you've deleted it. So just say yes. So now I can unplug my Pico and I can plug it into a battery pack. Okay, so it's been running in the other room for about 10 minutes now. So I'm going to come back and I'm going to plug it back into my laptop. And I'm going to press stop. Now the thing is, it's probably just taken a reading. So the last reading it took, I'm just going to ignore it. So the first thing we need to do is open our file. And then we need to do a file read, but we're going to do it in print because we want each reading to be on a separate line. So I'm going to come up here and expand my shell window. And there is a scroll bar on the side here. So you can see it's taken a lot of readings. So in here we have a challenge point, and this one's a little bit tricky. It says, can you figure out a way, such as copy and paste, to get your data into LibreOffice Calc or another spreadsheet program to create a chart? So what I'd like to do is get the file that's called temps.txt and put it into Windows. Now the problem is when I bring up File Explorer, you'll notice this PC, all I have on here is the C drive. The Raspberry Pi Pico doesn't show up anywhere on here. So what I want to do is show you how to get it into maybe the downloads directory. So what I'm going to do is I'm going to come over here to Thorny, and I'm going to go to View, and I'm going to click on Files. So you can see I have two areas here. One is the Raspberry Pi Pico, and there's the file that I want to copy. It's called temps.txt. Now up here is my computer, and you can see right now I have it set up for this computer, C, users, my username, and my downloads directory. So how did I get that there? So if I click on this computer, you notice it comes up with C drive. So if I open that up, down here I will have a directory called users. So if I click on users, then you find your username. So mine is right there. And then I scroll down and I can click on desktop, documents, or downloads. So I've been storing most of my information into downloads. So in my downloads directory, you can see I have a copy of the book, the RP2040 datasheet, the Pico datasheet, and MicroPython docs. So the next thing to do is to click on temps.txt. So do a right click on the file, and you can see here it'll let you do a download to C downloads directory. So just go ahead and click on that. Now when you go into Windows File Explorer and you go into downloads, you can see right at the top here is temps.txt. So you can go ahead and do a right click on that, and you can open it with, I have LibreOffice on my desktop, but you can also open it in Notepad. And you can see those are all the readings that it took. There's a scroll bar on the right hand side. So those are all the readings that it took. And like I said, the last one is probably one you want to discard, but all the other readings were from the other room. So this completes the video on Chapter 9. Now coming up in Chapter 10, we're going to be doing some digital communication protocols using I2C and SPI. So what we're going to be doing is hooking up your Raspberry Pi Pico board to an LCD display and displaying some messages on the LCD screen. So please don't forget to subscribe, turn on notifications, and I hope to see you on the next video. Thank you for watching.